Hey guys, it's Roya, and in this video I'll be talking about static friction. So Donald drives a soda truck, and it's filled to the brim with soda, so it's very heavy. Suddenly the truck stops, and Donald has to move it over to the side of the road, so he gets out and tries to push it. However, no matter how hard he pushes, he can't get the truck to move. Why is this? In one of the previous videos, we learned about kinetic friction, and the frictional force due to kinetic friction decreases the net force between applied force and frictional force. However, in this case, there's no movement whatsoever, which means there's no net force. If we were to look at a graph of frictional force, we'd see something that looked like this. If this is frictional force and this is applied force. Now let's go through and think about what this means. If we have a force diagram of the truck, we see that if Donald isn't pushing on it, if f of a equals 0, then the only two forces are mg and n. However, once Donald applies a little bit of applied force, then there is a little bit of frictional force. And this is, as we know, because the truck doesn't move, so there is no net force in the x direction. Now, let's look at, we can get rid of these. Let's look at if we were to have a much larger applied force. So this is F applied. Now suddenly, frictional force is also much larger, and this is why it has a direct relationship with applied force. Now sooner or later you get to the point where the truck starts moving, and this means that applied force is greater than frictional force. So if we were to draw it here, we'd have N and mg, and then we'd have a very big applied force and still a moderate frictional force. So the difference between these two is that during this relationship, the truck stays static, and this is why this refers to static friction. And here, in this relationship, the truck moves because there's a net force that causes acceleration. So this is for kinetic friction. Now once the truck is moving, kinetic friction stays constant. But static friction is increasing as applied force increases until this point. Therefore, when we look at the static coefficient of friction, U sub s, this is the maximum static coefficient of friction, meaning that if f of f equals USN, that is the maximum amount of static friction that exists, and that's right before the point when the truck is about to move.